right, I'm going to introduce myself. Hi, my name is Andre. I am the Manager of Organizational Programs for the Climate Solutions Accelerator. And yeah, I'd just like to welcome you to this month's AMPED webinar. While you are getting yourself settled in, as I mentioned before, and maybe a couple of new people just come in, please use the chat to introduce yourselves. A couple of notes, logistics. We have some time at the end of this webinar for questions, but we would like you to use the Q&A section of Zoom rather than posting those in the chat, just because if you put it in the chat, it might get lost in other people's introductions and things like that, and we might not see it. So please use the Q&A function for that. At the end of the webinar, we're going to have a little survey that we just kind of ask, how was it? Did you get what you needed? Was it interesting? So we'd really appreciate it if you take a couple minutes to complete that. And also anyone who registered for this webinar will get an email with the recording, PowerPoint slides, the survey, and also we're going to post the recording to the YouTube channel. So if you watch this and it's super useful, super helpful, feel free to go on our YouTube afterwards and reshare that with a bunch of other people, reshare it with your colleagues. We know that a lot of people enjoy watching the webinars that way. So let's go ahead to the next slide. Thank you. All right, so our agenda for today is introductions. We're going to talk about the goals of the webinar. Then we're going to do a overview of what is AMPED, for those of you who might not know, or for those of you who are new. Then we're going to talk about kind of the trends and the economics around electric vehicles, and then some of the supply chain issues and how EV production is working right now. Then we'll do our Q&A and we'll talk about next steps. So we have two, next slide. We have two great speakers today. We have Eric Hittinger. He is the Associate Professor of Public Policy at RIT. He focuses on energy systems and energy systems analysis, so he's got a wealth of knowledge in this field. And the other one is Brad McAreevy, the president of the Rochester Automobile Dealers Association. He's got nearly 40 years of experience in the auto industry, and the association represents a 10-county region of new car dealers in the area. So he'll be able to really help us understand some of the supply chain issues. Next slide. So our goals for today, we want to learn about procurement challenges. What are the causes of those procurement challenges? We've heard a lot, through these webinars and different networking events that people are having those challenges. So that's why we're doing this now. Try to dig into some of those long-term market trends. What's the context? What's happening with the supply chains? And kind of get a sense of what the forecast might be and the current state for availability of the electric vehicles that you need in order to really start going all electric with your fleets. Next slide. So as far as what AMPED is a campaign, and our goal is to mitigate the impacts of climate change by reducing carbon pollution caused by fossil fuels through the promotion of beneficial electrification in the Genesee Finger Lakes region. The two biggest sources of greenhouse gases in the region are transportation and buildings. And so to be able to impact those by helping people electrify their buildings, helping people electrify their fleets is really what we're heading for. And next slide. This webinar is made possible by our two main funders, the Climate Solutions Accelerator of the Genesee Finger Lakes region and Greater Rochester Clean Cities. So we would not be able to do this without them. Thank you so much to that support. In addition, if we go to the next slide, we have a steering committee. Thank you to the steering committee members and all their work in helping organize these and helping get the word out, and our creative partners as well for helping create all of this. And now, so we've gotten over all the sort of housekeeping and letting you know who we are. I'm sure you guys are really excited to move on to hearing our speakers. So I'm just going to hand it right over to our first speaker, Eric Hittinger.
Okay, hello everyone. So the first thing I'm going to talk about, next slide please, is sort of big picture view. So, I study energy transitions. I study clean energy economics, policy, and technology. So I'm going to give like the broad view of where electric vehicles are currently and kind of how they're expected to change and grow and interact with other energy systems in the near future. So next slide. So first thing I like to do in a talk like this is talk about motivation, right? So most people are here maybe because they're interested in decarbonization, right? That's why this was organized. And so from the global level, transportation is the #2 source of carbon emissions worldwide. I'm a little bit annoyed that this data set combines electricity and heat, but I promise you that if you break out electricity and heat, electricity system emissions are the #1 source globally, and transportation, gasoline and diesel is #2. So that's one of the main drivers for the electric vehicle transition that we're trying to pursue. But if you go to the next slide, this is a little bit different in developed countries. So in most developed countries, including the United States, electricity system emissions have been falling. So you can see here the red line has been falling, but transportation system emissions have not. And we're now at the point where vehicles transport uses more, has more emissions than electricity does. So if you take out the heat portion of electricity and heat, it makes transportation the #1 single source of carbon emissions in the United States. And this is especially true if you go to the next slide and look at New York State. There we go. If you look at New York State, almost half of the state's emissions are from transportation. So, if we want to decarbonize the economy in New York State and the United States in general, we need to decarbonize transportation as one of the biggest focal points of the attention. And electric vehicles are one way to do this, and probably the most feasible way to do this in the near term. So next slide. There's different forecasts for where we're headed with electric cars, right? We see them out on the road now. We see them more and more, actually, increasingly on the road. Different entities have different forecasts. One group that I think does a very good forecast is Bloomberg New Energy Finance. And they predict that most of the world's vehicles, 54%, of the sales will be electric vehicles by the year 2040, right? So that this growth in electric vehicles will be, pretty continual and up into the 2040s, 2050s, which would make the fleet of vehicles about half electric vehicles by 2040. But this is globally, and we expect countries like the United States to probably be somewhat ahead of this curve. This is an international forecast. If you look at like the International Energy Agency, they have a similar forecast. Everyone has their own assumptions and biases, but I think this is a pretty plausible forecast of where we're going. So we're probably moving towards a world with an increasing number of electric vehicles, but not a sudden shift either. And one of the main drivers for this, right, there's an interest in being environmental and reducing emissions, but, people care about dollars and cents. And EVs are getting to the point now where they have similar total cost of ownership over the duration of the vehicle, the lifetime as a vehicle, as a gasoline vehicle. And, this isn't just a thing that environmentalists say. This is a thing that, more impartial groups are saying. So here's Consumer Reports saying that EVs offer big savings over gas-powered cars. At total cost of ownership, savings can more than make up for their purchase price. If you go to the next slide, we have AAA saying they're about the same. So here's AAA saying you'll spend about $9,000 annually owning an electric vehicle, and that compares to about $10,000 for a minivan, $8,000 for a small SUV, $11,000 for a pickup truck. So about, the same general area of prices as those other vehicle options. And if you go to the next slide, it's Car and Driver magazine saying that for example, with the electric F-150 that just came out, they think it's somewhat cheaper, even without the tax credit, it's cheaper than the traditional F-150 by a small amount. The Kona electric, they find to be slightly more expensive than the gasoline version without the tax credit, but cheaper overall when you include the tax credit. So there's kind of some variability to this. It depends on how you drive. It depends what vehicles you're interested in, but certainly even the non-environmentalists agree that electric vehicles today are at least competitive when you consider all of the costs of ownership of these vehicles over their lifetime. This is probably going to continue to improve. So electric vehicles used to be quite a bit more expensive than traditional vehicles. It was kind of a luxury product. It was for people who wanted to reduce their emissions or wanted, to kind of show that they are adopting clean energy technologies, or, engineers who just like cool new toys. But these costs have been falling every year for quite a while now. And there's been an interesting study out of McKinsey, which is a consulting group. They did a nice report on EV costs and potential savings. So this is just the capital cost they're looking at, okay? The cost of buying the vehicle, not the total cost of owning it. And they basically took, on the far left, a traditional internal combustion engine vehicle, and they say, well, if you take out the internal combustion engine, that saves you about $3,000 from the vehicle, but you're going to need to add in a lot of batteries, about $10,000 of batteries. And then you have to add power electronics. It's another $2,500. There's a difference in the indirect costs because of volume. So electric cars, we don't sell very many of them. So their kind of shipment through the logistics system, the cost of keeping them on stock at a car dealership is kind of higher because there's not as much throughput of these vehicles. And that kind of adds costs to the cost of maintaining the stocks and distribution of these vehicles. But anyway, they figured that overall an electric vehicle is $12,000 to $13,000 more than a kind of similar internal combustion engine vehicle, just in terms of upfront costs when you buy it at the dealership. But if you go to the next slide, they first said, well, how much of this could be saved even without any technology improvements? So they looked at things like design simplification, optimizing the car for urban mobility, and then some partnership things in the distribution of the electric vehicles, right? Bringing down the costs for car dealers basically to stock these vehicles. And they figured that just these kind of non-technology improvements could save $5,000 to $7,000 on the total cost of the vehicle. So that still puts them higher than the cost of an internal combustion vehicle. But we also expect to see technology improvements. So if you go to the next slide. And the biggest driver by far is reduction in the cost of batteries. So I'm going to talk a little bit more about that in following slides, but the reason why electric vehicles have been getting cheaper is primarily because the cost of batteries that go into them is getting cheaper. And those batteries are the major cost contributor to the price of an electric vehicle. So if the batteries get cheaper, then the vehicles get cheaper as well. So according to McKinsey, if you take into account these expected improvements in technology, within 3 to 5 years, the upfront capital cost, the cost at the dealership for an electric vehicle, might be equivalent to the cost for an internal combustion engine vehicle within a few years. And I personally think that's a really interesting moment in the transition to electric vehicles. You can perhaps convince people that if they pay more for their electric vehicle today, over the course of 5 to 10 years, they'll save money on fuel, and the total cost of ownership will break even. But people really like paying less money today. So if an electric vehicle costs the same or even a little bit less than an internal combustion vehicle at the dealership, I think that's when consumer attention is really going to turn over and make electric cars suddenly much more interesting and attractive to consumers. So next slide. So battery prices. So we have these falling prices for lithium-ion battery packs. It's been actually really stark how quickly they've fallen in the last 10 years. And we have reason to believe that these prices are going to continue falling. And the cost of these battery packs keeps falling. If you go to the next slide, I think we have, yes, the cost of these battery packs are driven by what are called experience curves. So experience curves are something that has been well studied for solar power and wind power. So those are the first two here. And it's basically an observed relationship that we've noticed for these types of mass production technologies. As you build more and more of the technology, the cost of the technology falls. So we've seen this for all sorts of things: microchips, solar power, wind power, lithium-ion batteries, which are of interest for vehicles, but also lead-acid batteries, airplanes, all sorts of crazy things. We've found that as you build more of it, it gets cheaper in a predictable way. And batteries are falling along these same lines that we've seen for solar and wind, and they have a learning rate of 18%, which basically means every time we double the production of batteries for electric vehicles, the costs fall by about, on average, 18%. So, as this market grows and grows in the future, we expect to see adoption driving price decreases in batteries. And of course, we expect to see price decreases in batteries to make electric vehicles more attractive and drive more adoption of those electric vehicles. So it's a nice virtuous circle of technology improvement driving adoption, and adoption driving technology improvement. Next slide, please. So that's about the cost of the vehicles themselves, but electric vehicles are not identical to internal combustion engine vehicles. So if I have a gasoline vehicle, I can fuel it up quickly, and I can fuel it up more or less everywhere in the United States. So electric vehicles, though, have to charge. So how do we charge, and what are the energy sources for electric vehicles? How does this interact with the electricity grid, to be specific? So next slide. There's a lot of chargers out there. Most chargers don't have a sign. If you drive around, you probably see signs for electric vehicle chargers. Most chargers don't have a sign. But there's an awful lot of them out there. There's supposedly 50,000 EV charging stations listed in the alternative fuels data center. Most of those are publicly accessible and around neighborhoods. Not as many of those are on highways where we maybe need them. And there's some geographic access problems. So the chargers are not well spread. They're mostly in cities. They're mostly in the places where people that drive electric cars are most likely to be. So we have some access issues. Another access issue is home charging. So for most of us that live in houses, charging an electric vehicle at home is not a problem, but there are a lot of people that live in apartments, and if we want to make electric vehicles accessible to them, we need accessible public charging. Another nuance to this difference that I'd like to highlight is the importance of fast charging for long distances. So we're starting to learn that the way people use electric vehicles means that they have two different kinds of charging needs. Most cars spend a lot of their time driving locally. And if you drive locally, you can charge at home slowly, or you can charge in a public charger slowly. Slow chargers work fine for your needs. But if you want to drive to Washington, D.C., you want to drive long distance road trips, which we do infrequently, but they add up to a lot of miles, what you're really looking for is a fast charging opportunity along a highway, usually. So this is what we want to see, is like local slower charging to meet people's needs for local driving, as well as fast charging on highway systems. And we're starting to see those fast chargers come around, but they're a lot more expensive and they're being adopted more slowly. So if you go to the next slide, the Biden administration and the infrastructure bill that was passed actually earmarked a lot of money to support growth in chargers. And these include the two kind of important, what I would highlight is the two important portions of this market, trying to get charger access more broadly geographically, and also trying to get better fast charging support along long distance routes so that people who drive their electric vehicles long distances have that charging support. So if you go to the next slide. So here's a map of where the chargers are around Rochester. So just like those earlier reports said, there's a lot concentrated in the city. There are some concentrated in the areas of likely suspects, the kind of upper middle class neighborhoods where you'd expect early adoption of electric vehicles. But you can also see large areas where there's few to no electric chargers. And when you look into the details on this map, most of these chargers are slow chargers. So we want to see more fast charging, especially along the highways, along rest areas, for example, in Route 90, which I should add is actually one of the priorities of the state. So if you've driven along 90 in the last year or so, you may have noticed that the state is redoing all of the rest areas along 90. And they are including fast chargers in every rest area when they make those upgrades. So we'll have pretty good fast charging service along I-90, but that's just one highway in America, and we need to see that more broadly. So next slide. I want to talk about the electricity grid and the charging. So people don't necessarily know this, but I love to brag. Upstate New York, it's the best place in the US to charge an electric vehicle. Electricity is pretty cheap. It's below average. It's not the cheapest place in the US, but it's relatively affordable. And upstate New York is the cleanest electricity grid in the United States. So this is a figure from the Union of Concerned Scientists, and they basically did an analysis that said, if you charge from the standard electricity mix in this area, given the emissions from electricity, what would be the equivalent miles per gallon to get the same emissions from an internal combustion engine vehicle? So basically, if you drive an electric vehicle in upstate New York, it's like you're getting 250 miles per gallon as far as the emissions are concerned. So that is very good. So next slide. The other question that comes up sometimes is, well, what will happen to electricity grids with all this new electricity demand? And it's a very complicated question, but I think the simple answer is the grid can handle this. It does increase demand. So on the left side is the 2018 electricity demand. And then there's a 2050 reference case where vehicles are not electrified. So in any case, we expect to see a 30% growth in electricity demand by 2050. But this analysis from NREL says that if we electrified almost all the transportation in America, that would drive an additional 40% increase in electricity demand. But that's over about 30 years. So we're talking about 2 to 3% additional demand per year for decades to come. And that's not nothing, but it's a manageable growth in electricity demand over the next few decades. And if you go to the next slide, I also like to point out that this question about can the grid handle it is less about the total amount of additional demand, but more about when and where that electricity demand shows up. So this is a figure from a different NREL report. So it's the National Renewable Energy Laboratory report. And they point out, so in the upper right, that charging right now takes place mostly when people get home from work. So when people get home from work, they plug in their electric cars and then they start charging them. But when people get home from work is already the peak electricity demand period. So we would like to not see electric car demand being added to the peak period of electricity demand. That makes it rather hard for the electricity system to operate. What we'd rather see is something like the bottom right, where electricity demand from electric cars can be placed in the periods where we have the least amount of natural demand, or when wind or solar power, other renewable sources are producing. So this makes it more achievable for the electricity system operator. So if we do this right, we can increase demand by 40%, but not really increase peak demand at all. That makes it very feasible for electricity system operators to meet all this demand. So finally, next slide. That was kind of the wrap up. If you have questions or complaints, you can contact me, or we have the Q&A for later. And I know I went 2 minutes over time. I apologize.
Thank you so much, Eric. Yeah, so again, please drop any questions into the Q&A. We will look at those at the end. But now we are going to talk about some supply chain issues. And so Brad McAreevy, you're up.
Thank you, Andre. I think I've got my video running. Can you see me all right? Okay.
Yes, we can.
So I guess I would start off, as Andre mentioned, I represent about 100 franchise new car dealers in 10 counties. I work in the Western Central New York area, but I also work cooperatively with our national association. So, Eric's information obviously is very interesting. I will say that some of the information that I get it from different places. It sometimes leads you to a slightly different conclusion. Doesn't mean either one of us are right or wrong. It just means we're getting different information. And I think it's worth mentioning that some of my statistics might be a little bit different. I think it's fair to say that the auto industry is going through the most dramatic transition it's ever gone through in the 100+ year history of the industry. To move away from internal combustion engines to electric vehicles is going to be a significant transition, and the industry is certainly going that direction. And all monies, investments, resources, everything is being put toward making that transition happen. And again, on a alternative fuel basis, electric vehicles are by far the most talked about, most heavily invested technology that's currently in the market today. I think it's worth noting, though, that there are other technologies that are also being explored. They're just not getting the same amount of attention that electric vehicles are. And examples of that would be hydrogen and hydrogen fuel cells. That technology has a lot of potential, especially in the heavy duty truck, bus industry. Those types of technologies look like they have a lot of potential in that area. Volkswagen recently partnered up with a German company called Kraftwerk. They've patented a technology with some fuel cells where they're now looking at a vehicle that could get up to 1,200 miles of range on a fuel cell technology. It utilizes a ceramic membrane as opposed to a polymer membrane. It's much less expensive, and it doesn't need certain precious metals that the polymer ones do. So also, one of the technologies I find really interesting, it's not something you're going to hear about anytime soon, but Porsche, the automaker, and Siemens are currently in a joint venture in a factory down in South America, and they're developing a synthetic fuel that burns almost completely carbon-free, which I think is pretty interesting when you think about the idea of being able to pull up to a current gas pump and being able to put synthetic fuel in your car as quickly as you put in gasoline, fossil fuels today, and being able to take off and be able to meet all the climate objectives that we all, as a nation and as a world are looking to achieve, but doing it through a synthetic fuel concept. So I think it's worth pointing out that there are other technologies out there. They are being developed. They are being explored by different manufacturers, and I think you're going to see it at some point. But certainly today, EVs are the primary focus. Next slide. Actually, I just spoke to that one, so let's jump forward one more. Okay. So I want to try to tackle this, I guess, in 3 different ways. I want to talk about government and its role and what's happening. Then I want to talk about the manufacturers that are in the industry. Then we'll talk about dealers, and then we'll talk about consumers, because I think it sort of makes sense to flow that way. I think it's pretty well known that the current federal administration is very, very active and focused on climate change initiatives. They're putting a lot of money into it. They are taking steps toward achieving strong objectives in that area. And obviously the auto industry, as Eric pointed out, is a major player in really change as it relates to emissions control. The government did recently pass legislation that does allow for incentive money to be provided to the development of publicly charging stations. It's a big investment. They're also providing tax credits to privately owned businesses that are willing to install charging stations, but as long as they're available to the public. The other thing that we obviously saw here in the last couple of years is the impact of the microchip industry and how that's affected the auto industry. And just quickly, I'll go back and tell you kind of how we got to where we are today. The auto industry has been utilizing microchips for years. That's no secret. When we first entered into the COVID pandemic, the expectation is that the sales of vehicles was going to slow down dramatically. So many of the automakers, in looking ahead to try to manage their supply chains, they contacted the chip suppliers and essentially told them that they weren't going to need the amount of supply that they had previously ordered. So they suspended their orders. The chip manufacturing companies took that and essentially redeployed or resold that supply of microchips to other industries that were growing, computers being one, because everybody started working from home, and the computer industry took off, and of course the cell phone industry and other industries that actually grew as a result of the pandemic. What then ended up happening is the downturn in the auto industry was not as dramatic as was expected, and the automakers went back to the chip processors and said, look, we now realize we're going to be able to produce cars again. We need the supply of the microchips. And the companies said, we're sorry, but we've redeployed, that supply. That's what created the shortfall in the auto industry. And frankly, it's never caught up at this point. Go a step further, the auto industry utilizes a generation of a microchip that's actually not the latest and greatest. Phones and computers utilize a newer generation chip, but the auto industry utilizes a chip that's, in their view, more reliable, more durable, and a chip that's proven itself to work in autos. They're very concerned about safety when it comes to autos. When a computer chip defaults or doesn't perform, it's potentially harmful to people. And so the industry is very careful about moving to new generations. That's also playing into the microchip situation. But where we went from there is now we're in this situation where we're playing catch up with the microchip industry. Then we start looking at the global supply chain issue. The big suppliers of these microchips are foreign countries. China, Taiwan are major suppliers. And of course, the US politically is looking to try to become more self-sustaining. And so they want to bring these manufacturing facilities back onto United States production facilities. And so that's another effort that's sort of driving where we are today. Interestingly, while you would think the auto industry and the microchip industry would be racing to meet whatever catch-up demand there is, that industry, in a very, very recent article I just read, they actually are seeing a downturn in their production levels because computers and phones are actually declining in sales now. And those are big buyers for them. So even though the auto industry is on this situation of needing more, the microchip industry as a whole is actually leveling off and even forecasting to be in a downward trend. So there's a little bit of a conflict going on with that. Next slide. So talking about New York State government for a little bit, New York State is in lockstep with the federal government right now. New York State is very committed to climate change initiatives. On the fourth bullet I mentioned on there, they're a CalZEV state. That means that New York State follows the California Air Resources Board when it comes to setting emission standards. There's a handful of states in this country that follow California, and New York happens to be one of them. New York introduced the NYSERDA Drive Clean Rebate Program back in 2017. That program has had in excess of $100 million in funding given to it. It's a rebate on the purchase of an eligible EV or hybrid, plug-in hybrid vehicle. Rebates range anywhere from $500 to $2,000. They're based on the range of the vehicle. And then there's a price limit. If its cars has a MSRP over $42,000, it gets the $500 rebate. Anything above that, $500. But it's basically driven off of range of the vehicle. New York State also has what's called a Make Ready EV charging station program. This sort of, I think, dovetails into the federal program where they offer reimbursement money and incentive money to private businesses that are willing to install charging stations and make them publicly available. They will reimburse that business owner for the costs of installing essentially the conduit, the power source, all the work that would go into installing the charging station. They don't pay for the charging station itself, but they will pay for all of the preparation and reimburse you, not 100%, but it's a very good program, and it's a program that a lot of companies have taken advantage of. I can tell you in our world where many dealers are required to have charging stations on their properties by their manufacturers. Many of the dealers have taken advantage of the Make Ready program, but it's available to anybody that wants to utilize it. Let's see. Let's go to the next slide. So again, both levels of government are very committed to this program. I think politically, we all just obviously came through a midterm election situation. We now have some slight changes in terms of control of the legislature. We don't anticipate any rolling back of any of the initiatives of the current administration, because both parties have said they strongly support the idea of the United States being somewhat independent in terms of its manufacturing capabilities. They support the idea of producing microchips in this country, and they also support being able to essentially support the development of electric vehicles with very little need for outside supply chain. So despite the fact that we've now seen a shift on some of the political fronts, we don't think that that's going to have much of an impact. It may affect further development or rollout of additional programs, incentives, things of that nature. But at the very least, it will remain status quo for the foreseeable future. Next slide. So jumping now to auto manufacturers, there's literally billions of dollars being committed to battery manufacturing in the US, billions of dollars on new and renovated manufacturing facilities. Most of this is being done to take advantage of the federal and state incentive money that's being offered. And then also to be eligible for the federal tax credit, which is contingent upon location, materials, and manufacturing. So the Inflation Reduction Act that was approved earlier this year changed the requirements in order to be eligible for the $7,500 federal tax credit. It now requires the car to be manufactured in the United States. That was effective immediately. And then starting in January of 2023, the minerals associated with the battery development and the battery assembly itself also have to be manufactured in the United States in order to get the full $7,500 credit. And the last part, the battery minerals and the manufacturing, has a phased in transitional period. The concern, while I think everybody understands the goal and objective of trying to, this is a U.S. incentive. The goal was to bring the manufacturing and all the mineral acquisition, so forth, all into this country. And I think everybody can understand the goal, but to do it in the time frame that they did it, it's actually going to set back the sale of EVs because the auto industry is a worldwide industry. There are a lot of manufacturers that import cars into this country, that would otherwise be eligible for the credit that as of today are not eligible. The mining of raw minerals and the development of batteries, that stuff is not going to take place here in this country in the next 2 months. So the concern is that while the long-term goal makes sense, acting on it in the time frame that the government is acting on it is going to actually result in fewer EV sales in the near term until the manufacturing and all the rest of it can be brought into this country. As a result of that, there's been some very recent legislation introduced, frankly, I think in the last week, where the Senate has proposed to delay the implementation of those requirements and phase them in over a period of time so that we don't set back the sale of EVs by taking the incentive money away today, but in fact, sort of gradually move into it. Everybody is still intent on bringing this manufacturing and raw material development into this country. They just want to do it in a timetable that can be met. So that's an important aspect of it. Next slide, please. The manufacturers right now, it appears, and I should say, that they want to own their supply chain. They want to vertically integrate their system. So they're aligning themselves with companies that provide raw materials, with technology companies, with battery development companies. They're all kind of scrambling to align themselves with a company that will be a supplier to them. And they're trying to sort of set up their own supply chain and their own channel of distribution and manufacturing so they can compete in the market. And it's kind of a race between the various manufacturers and aligning themselves with these suppliers and these tech companies who can help them meet these goals. And it's just part of the industry. I mean, everybody is trying to get a competitive edge, and so they're out there trying to align themselves. Ford Motor Company recently took a step, and they actually separated their internal combustion engine business from their EV business. They actually have broken them up into presumably 2 completely separate divisions of Ford Motor Company, and they're going to operate them independently of one another. It's an interesting concept. It has some issues. We'll have to wait and see if that in fact works out. But the bottom line is virtually every manufacturer in the auto industry is taking steps toward getting into the EV game. Some of them are just further along than others, but everybody is going that way. Again, aside from these other technologies that are also being worked on by other manufacturers. So it is clearly where things are going. On the manufacturer side also, again, I mentioned about the microchip shortage continuing to take a toll. The short-term capacity of the industry is expected to rise. So the chip industry is actually increasing its productivity, but the demand that's out there right now and the number of chips that go into a specific vehicle are also increasing. So it's really just trying to get the capacity to catch up to what the demand is out there and where the technology of the vehicles is going. And it's a struggle. I can't really put it any other way. As I sit and read articles about where production levels are going, I read an article almost every other day that says production levels are now forecasted to drop another 500,000 vehicles in 2023. I think the number right now is somewhere between 3 and 3.9 million cars are going to be taken out of the production chain for 2023 due to microchip issues. So now let's take a quick look at where we are on the dealer side of things. So what does this mean for dealers? For the past couple of years now, they've been running with unbelievably low inventories, and you all see it when you drive by a dealership right now. Somebody that might have had 400 or 500 cars on their lot might be sitting there now with less than 100. That has driven consumers' behavior to change. They're starting to do more shopping online, and it leads consumers to ordering vehicles as opposed to the old way of going to a dealership and finding the car you want on the lot and buying it and driving off in it. The ordering process changes sort of the negotiating that goes on. Dealers, when they have those kind of inventories we talked about earlier, they're highly motivated to sell them. So there's oftentimes price negotiation that goes on. There's a lot of incentive money that typically would be in the market. When you have very little inventory and the manufacturer isn't producing, that whole scenario changes. And all of a sudden, the price is not negotiable and there are no incentives. And consumers are basically faced with, I order the car, I pay whatever the price is. And the good news is I'm going to get a vehicle. That's the end result. Some manufacturers have implied that they like this method of selling cars because, you know, everybody's paying full sticker for it. And there's not a lot of incentive money being put out there, which is a cost to a manufacturer. But when we get past this whole situation where these constraints are out there, I find it hard to believe that manufacturers are not going to want to go back and put inventory out on dealers' lots, and consumers are not going to want to be able to buy a vehicle and take delivery of it, as opposed to waiting 2 or 3 months, take delivery. Dealers are also being asked to invest heavily in the EV future. They are being asked to enhance their facilities. They're being asked to put significant dollars into training. They also have to buy special service equipment. It's a very, very significant investment, and on top of putting in charging stations. So it would not be uncommon for a dealer to be asked to invest $500,000 to $1 million just to be able to sell EVs, and the number could even go higher than that. Next slide. So ultimately, where does this leave consumers? Again, limited inventory for the foreseeable future. I don't really see that changing dramatically going into 23. Consumers should definitely, if you need a vehicle, seriously consider ordering the car. The average wait time is about 6 to 8 weeks. The one thing ordering does allow for is it allows for customization of the car. You literally go on and order the car specific to the specs you want, the color scheme, the equipment, et cetera, et cetera. So in that sense, you're getting the vehicle that you really want. Basically make sure that you talk to the dealer about whatever federal and state incentives might be eligible, when you work through that process. Next slide. Okay, and the last thing, as consumers are buying EVs, the one thing they need some help with is installing charging stations in their home. We actually provide some assistance with that. There are some companies here, obviously locally, that do that. We have some partners out there, and the Dealers Association is here not only to help our dealer members, but to help consumers with that decision about how they go about getting a charging station installed. So I think that's about it.
Thanks, Brad. That's some interesting information. We have one more little thing before we go to Q&A, which is what about electric trucks? So David Keefe from GRCC spoke to a representative from BYD, which is a commercial electric truck manufacturer, because people have been asking also not just about consumer vehicles, but other more heavy duty vehicles. And it says, I will say lead times from BYD are no different than the lead time for a diesel truck, about 12 months. Truck fleets are familiar with these long lead times for diesel trucks, as this has been the case for over a year now, and it's looking like it will continue for a few more years. What's important to remember about procuring an EV truck is that you have to have your infrastructure in place before you receive the truck. Some infrastructure projects can take well over a year to complete, depending on the work that needs to be done to the site. So that's a whole other thing to think about, is getting yourself ready for things like that. But it looks like there's lead time on heavier duty vehicles as well. So let's go to the next slide. We have some next steps that you might be able to take. Again, as Brad mentioned, if you want an EV, get your orders in the pipeline now. Look at a local dealer, ask about what they have in inventory that you can take a look at or test drive. The Rochester International Auto Show is coming up. So if you want to see some more EVs, you can go there. And also subscribe to AMPED to get the latest updates, or contact David Keefe, who I mentioned, because he can really help you with the conversation about how to electrify your fleet. AMPED in general also has other resources. If you go on our website, there's lots of articles there. We have blogs. If you go on our social media, you can follow us. We're on LinkedIn, we're on Facebook, and you'll be able to see the upcoming events and also the blogs and stuff coming up. One next event that's coming up is going to be about grid reliability, which I know Eric touched on, and it's an interesting thing we've heard a lot of conversation about. That'll be January 19th. And so with that, let's go straight to Q&A. If you would just put any questions you have in the Q&A field, Sarah Studwell, who makes all this work, is going to kind of facilitate that.
Awesome. Thanks, Andre. And thanks to those really informative and interesting presentations, both Brad and Eric. Thanks so much. So we have a couple questions that have come in through the Q&A feature. If you have more, now is your chance. Our first one is for Brad. So it's a question from Clement Chung from Monroe County. Do you think that EV battery technology will be more universal or more proprietary as the industry moves forward? For example, in the lawn, landscape, and consumer industry, manufacturers are banking on the value being held in swappable batteries. And once a customer purchases one device, they kind of feel locked into buying all the equipment from the manufacturers, since they don't need too many redundant batteries. So what do you think about more universal or more proprietary as the industry moves forward?
Well, so just so I'm clear, we're talking about batteries. Are we talking about charging? You know, the commonality of charging. The industry, I think, recognizes that the charging port and the charging units that are out there, the consistency of it is vitally important. People need to be able to go to any charging station and be able to charge their vehicle. And so I think the industry has recognized that. To the best of my knowledge, almost every EV in the market, with the exception of Tesla, is compatible with the charging network that's out there. Tesla does have a unique charging port and a unique charging station network. But beyond that, I think every manufacturer and the charging companies, the ones that install charging stations around the country, they're all compatible. Regarding if it's about battery technology, I think you're going to find that it's a very competitive market. You know, General Motors is into Ultium batteries. I think the end result is, if you look at the companies that are looking down the road, the lithium-ion battery is actually going to be replaced with solid-state batteries. Solid-state batteries, they charge quicker, they last longer, they have a longer range, and I think the technology is going to move us into that next generation. And you know, will it ever be completely common ground? I can't really answer that, but as long as the charging capability is there for everybody, I think the consumer should not be disrupted by that.
Great. Eric, anything to add?
No, not much. Just that yeah, I mean, the batteries are they're kind of integrated into the vehicle. So unlike the kind of yard tools that the question asker was mentioning, you know, batteries, you know, just like engine design, right? If you buy a car, you more or less get the engine design that the manufacturer has chosen for that vehicle. And the same thing is probably true for batteries. And I agree with Brad. The more important question, practically speaking, is in the charging network compatibility. Yeah.
Thanks. Our next one is, how is this procurement process going to be different for larger fleets? So maybe the question asker is asking about bulk purchasing.
Yeah, you know, so I work obviously on the retail side of things. You know, I don't think that the manufacturing side of it and the supply side of it is going to be dramatically different for a fleet buyer. Especially if you're looking at a fleet of light duty vehicles. So, you know, 1/2 ton, 3/4 ton pickups, vans, you know, SUVs, those types of vehicles. So they all come off the same assembly line. They're just, you know, some companies need large fleets of them. Those buyers typically deal with the fleet departments of various manufacturers. You know, you can go through a dealer to work through the fleet manufacturer, but I think they're gonna run into the same constraints that the retail industry runs into in terms of capacity, the ability to time frame to meet the order, that type of thing. And that's why, I would encourage anybody if you're in the market and you need a vehicle, I would be acting as quickly as possible to get something in the order bank.
Mm-hmm. Thanks. Another one, I think for Eric, do prices at charging stations fluctuate like gas prices?
Well, they don't fluctuate so much over time like gas prices do, but they fluctuate by location. I live in Brighton, and the town runs a free charging station over here. So 0 is a great cost, and it's always been 0. Other charging stations can be really expensive. Usually fast chargers charge you quite a lot for electricity. So it doesn't vary with, basically gas stations mostly charge more or less the same price at any given moment, but the price everywhere goes up and down together. With charging stations, the prices are still more variable. I don't think that the kind of market structure for electric vehicle charging is really settled on a final state. So we're probably going to continue seeing some variability there. But the real practical thing that I'd say is even the most expensive electricity charging for your vehicle usually costs at most as much as it costs to fuel a car with gasoline. And usually much less than that. So it's a less important question because electricity in general is a cheaper fuel source.
Mm-hmm. Thanks. And I think we have time for one more. This one's for Brad. How can I determine what state and federal incentives my vehicle qualifies for?
So in New York State, you can go right on to the NYSERDA Clean Rebate website. It's publicly available. If you just Google NYSERDA Drive Clean Rebate, you'll get the website for the New York State, and it lists all the vehicles that are eligible and what their rebate amount is. So it's very good. It's a great website, gives you a lot of information. On the federal side, the federal tax credit, if you're talking about, again, a retail purchase, I was trying to describe to you how that rebate has changed. And it does require, I think, a little bit of help from the dealer. The first question you have to ask, was the car manufactured in this country? If the answer is no, then it's 0 as of right now, unless this legislation that was introduced goes somewhere. If the answer is yes, it was, and then you move to the next step is, okay, where were the minerals acquired? Where was the battery built? And you start to sort of figure out how much of a rebate you're going to qualify for. That rebate is in the form of a tax credit. You get it when you file your taxes. The good news is there is a lot of effort being made toward moving that to an on the time of purchase rebate, similar to what New York is. New York is a rebate at the time of purchase. We want the federal rebate. We want the federal tax credit to also be a rebate at the time of purchase. We think it's a bigger motivator to be able to get it right at the time of purchase. But the federal one takes a little bit more work because you got to find out where was the car built, where was the battery and so forth, and to figure out how much of a tax credit you would qualify for.
Great. Thanks so much, Brad and Eric, to Andre, our MC. If you had more questions that we didn't have time to get to today, you have the email addresses in the chat for Brad and Eric. You can contact AMPED at info@ampproject.org. We're really grateful that you chose to spend your time with us today, and you'll get an email follow-up with those slides, the recording, and any next steps. So thank you so much and have a great rest of your day.